My name is Matt Etherton. I'm a professor at Virginia Tech, and we're going to be talking about the design of steel deck diaphragms. I'll start with an introduction to diaphragms and what we're going to cover in this webinar. We'll talk about the seismic design approaches for diaphragms in steel buildings. We'll talk briefly about bare steel deck diaphragms, and we'll drill down more on concrete-filled steel deck diaphragms, as you can tell by the subparts. We'll do an example of a concrete-filled steel deck diaphragm, and then at the end, we'll look at some analysis results that tell us if we design buildings with these procedures, what kind of behavior during a design earthquake might we expect. So we'll start there with the introduction. And the question, we got to start with the basics. What is a diaphragm? I think the most basic definition of a diaphragm is the portion of the lateral force resisting system that's acting in the horizontal plane or near to the horizontal plane if we're thinking of inclined roof planes. For lateral loads, particularly seismic lateral loads, we might think of Newton's second law as a place to start, which can be phrased as the inertial force is equal to the mass times acceleration. Most of the mass in a building is either in or attached to the floors and roofs. So a lot of the inertial forces originate in the diaphragms. The diaphragms transfer those loads to the vertical frames and down to the foundations. Now, wind is just slightly different load path in that we're thinking of pressures on the exterior faces of the building, which is some proportional to some constant times the square of the wind velocity. Those pressures are applied to the faces of the buildings, and there's wall framing that spans that load up and down to the floors and the roof. Once the forces are in the floor and roof, the diaphragm action is the same. The lateral loads are transferred to the vertical frames. So to summarize here, diaphragm is a portion of the lateral force resisting system acting in a horizontal plane, with some exceptions to that horizontal plane part. The diaphragm transfers lateral loads to and between the frames, and it's a critical part of the lateral load path. In North America, we idealize diaphragms as a deep beam. And consisting of, I'm going to break this into 4 parts. So consisting of 4 parts, the first part would be the deck, and this might be the bare steel deck at roofs or the concrete-filled steel deck at the floors. We picture these as just transferring shear forces and nothing else. And then separately, we have discrete elements that we call chords that resist the flexure in the diaphragm. Along the edges of the diaphragm spans, in line with the braced frames or moment frames, we have collectors where the shear is collected and transferred into those vertical frames. And the final component, sometimes overlooked, is the shear transfer. And this is the connectors between the diaphragm and the collectors, or between the diaphragm deck and the chords. And those are an important part of the diaphragm system. There are several references that are necessary if you're going to be designing diaphragms in steel buildings. ASCE 7, the version in 2022, actually has 3 different procedures for designing diaphragms. There's section 12.10.1, which is the conventional diaphragm design procedure, and that's the procedure that we're used to using, we've been using for years. 12.10.3 was new in 2016 and has been expanded in 2022. This is called the alternative diaphragm design procedure, and we'll talk about that in the coming slides. And then there's another section in 2022 that's new, 12.10.4, which is related to rigid wall flexible diaphragm structures. Picture a tilt-up concrete, a big box store with a light, either metal deck or wood panel roof. But we're not going to talk about this part during this webinar. AISC 341.16 has requirements for diaphragm design and studs. We'll talk about those through the course of this presentation. AISC 360, the steel specification, this is where we get the strength of the headed shear studs. AISI S310, this is the location of our latest equations for strength and stiffness of these diaphragms. This is the latest research, latest equations, and we've been working on updating that in the 2020 edition and again in the 2024. There'll be even more updates. So that's an important reference for steel deck diaphragms. AISI S400 is related to seismic design, and this is where we'll find what is called the special seismic detailing for bare deck. We'll talk about that in this presentation, but those are located at S400.